Okay. Well, I took a slightly different tack in the MOOC that we taught. Now, this was one that Rob Clark and I taught. It started last June 3rd, so if you want a great way to ruin your summer vacation, teach a MOOC that starts June 3rd, because I worked from graduation, well, the whole month of May, getting ready for it, and then right through July. So anyway, what we were trying to do in this MOOC is in engineering education. It's a little different kind of critter, and we're trying very hard to teach students how to do things. And so how in the world are you going to do that online? And so this was very much an experiment, and it had some marginal success, but it was an interesting experiment. So first of all, I'm just a very firm believer in learning by doing. And I think any engineering student or science students, they don't really understand it till they see an example or do it. And so I found a couple of nice quotes. There's a fellow who's the president, Richard Miller, at Olin College. So he likes the approach where students learn best when they attempt to do things first, and then when they can't do it, they go and they learn how to do it. And so you can take that to an extreme, because you would hate to have to discover calculus all on your own, I think. But anyway, that's sort of interesting. But the quote I really like is Alfred North Whitehead, who said, "A merely well-informed man is the most useless bore on God's earth." So I don't think this isn't exactly what he had in mind, but I like that quote anyway. That guy must have been a real card at the faculty senate meetings. I can just imagine. It's a lot of fun. So I'm not going to stand here in the education school and try to give a talk about educational philosophy or something like that, but even engineers have discovered this thing called Bloom's taxonomy, which is, I got to fix this here. I got a problem. Okay. So and so this is kind of a useful framework to keep in mind when we're trying to figure out what exactly it is we're trying to do. So at the lowest level, there's just learning some specific terminology and facts. Then you graduate to recognizing the general principles within the field, and then hopefully start to comprehend what's going on, and then start to apply the knowledge, and then really analyzing the field at large comes next, and then sort of synthesizing and getting a global view of what you're learning, and then being able to stand back and evaluate your own work and critically look at other people's work. And so if you look at that framework, MOOCs as they existed sort of take you through the first few steps, perhaps. And so what we were trying to do is go a little further and actually apply things and get people to think about what they're doing. And there's nothing like actually building something to encounter reality. Simulation can only go so far. I like to say the space for things to go wrong is much bigger in the real world than it is inside a computer. And so it's very important to do things in the real world, because there are failure modes that you would never anticipate in 100 years. And we're in the business of trying to avoid all those failure modes. And hopefully what we're doing here at a residential university is taking the students all the way to the end of the road here. And so that's kind of the framework that I like to think about this in. And so the course that we taught was a 6-week course, Introduction to Acoustics and Electronics, basically. So Rob taught some acoustics lectures, and I taught some electronics. And the whole thing was designed around integrating everything into a project that we figured a lot of people would want, and that's to build a little 10-watt guitar amplifier. And so we teach them everything they need to know about how the electronic circuits work, and then how the speaker and the enclosure and all that works. And so we took them from ground zero up to being able to understand and build that thing. So we discussed both how to do things, but more importantly, the course was really about why. We used sort of high school, first-year college level math, and I was looking at Eric's statistics there. And And it's embarrassing to see that our completion rate was way lower than the history of rock. Well, I blame that on Rob, because one day I was looking at his notes, and some of my scientist friends will appreciate this. He out of the blue started talking about spherical Bessel functions. So what the hell's wrong with you, Rob? And so then he started using complex exponentials and stuff. So I had to go do a whole week of lectures just on that stuff to backfill that. And so anyway, huh?
I would have been enrolled.
Yeah. So it's just just natural, and I think probably the biggest limitation in my mind was the testing and assessment that you can do in this kind of a domain is just too limited. It's just multiple choice, and in fact it's a whole game. You set it up so you get to take the test multiple times, and so you don't get to do each question multiple times. You have to do the whole test, and so if you blow it on 50% of the questions, you don't know which 50%, and you do the test again, and so it's you can imagine the phase space for gaming that system, but it's that's I think a real problem that needs to be fixed. Now I just wanted to show a couple of examples. Here's some of Rob's, a little bit of one of Rob's.
That's just a simple demonstration of a capacitor, okay? What I'd like to do now is convey something that's very important about why we actually have transducers in boxes. And I've intentionally, with this...
This is interesting if you don't know this. So what? This is why your speakers come in boxes.
Remove it from the box itself. And let me pop these off. All right. So what I'm going to do now is I want you to be able to hear the sound radiated when the speaker is in the enclosure, and then I'm going to pull the driver out and we're going to play it. So I want you to hear the difference between those two. So let's start with it in the enclosure. And that's out. Hear the low frequency come in.
So
lose the low frequency when we pull the driver out of the box.
So you get the idea there. And then I had wonderful help from one of my PhD students, Dave Anderson. And Dave designed a, he actually...
They're not actually supplying a case with a kit.
He designed the guitar amp.
The circuit is designed to have a soft clipping effect, which uses diodes. Now there are two types of distortion that you'll find in guitar amps. There's a soft clipping effect and hard clipping effects. Distortion is created when an output waveform is chopped off at the top and does not appear smooth anymore, but is rather straight along the top. Now, a soft clipping effect...
So you get the idea, but it helps to have graduate students who can play the guitar. And then, I came in and just bored everyone with talk about, diodes and stuff.
Now, when you look at forward bias,
so you already know what I sound like. I'm standing right here. So we couldn't have done this course really without Eric's help and Will's. Will did a wonderful job in putting this all together. And Eric is the most patient man in the world, because here it is. It's like Thursday, and we have to have the video up on Sunday night, and I'm still goofing around trying to make the video. And he's just cool as a cucumber. He said, no problem, we'll get it done. And we did. Okay, so there's a few, Eric kind of went over this, but we started with 30,000 registrants, and we had around 18,000 people still active after a few weeks. The thing that I thought was really interesting about this is this signature track registration business. Now, people actually paid some money. I forget how much it was. It was like $50 or something like that. 39. Okay, so that was the opening. It's the discount for early adopters. But people actually paid money to get those registrations. And now we made this guitar kit. We didn't sell those things ourselves. We found a company that turned it into a kit and sold it. But 375 people actually bought those things and put them together. Most of them put them together. And the study group formation was pretty interesting. From all over the place, from Colombia to the Philippines and different parts of the U.S. And it's kind of cool to see that happen. And the forum in our course was very active because people were helping each other. And there were 450 different threads that had started, and each one probably had 20 to 100 comments in it. And so there's just a huge forest of correspondence going on back and forth. So basically what they learned in the course was you show them that, and no one knows what that is, and then after 5 weeks they understand every detail of that schematic for a guitar amplifier, and they can build it and know what they built. So it's not just building a kit sort of blindly, it's really understanding. And it was neat that one of the forum threads, people showed their completed projects, and so some people really got pretty extravagant, building nice cabinets and stuff like that, and so it was pretty cool. My favorite one was this guy who built this in a nice silver box, and he said it's a great project. He managed to, with spare parts, to build the whole thing for $2.40, and he completed it just in time to start the Coursera course on Intro to Guitar. So it was the feeder course for the Intro to Guitar. So that's what happened. Now I just wanted to close with a few observations and maybe some thought-provoking comments. We're supposed to have discussion, I guess. So one thing, if you're going to do this, and John said this is not for assistant professors. I found took me about 10 to 1, 10 hours to prepare 1 hour of stuff online. It's way harder to do this than a live lecture because there's no one looking back at you with a blank look on their face. And when I teach a course and the students are sitting there unresponsive, I say, look, you're in one of 3 states. I ask a question and they just sit there like a lump, and I say, well, you must be in one of these states, and I want you to raise your hand. So it's either I understand, I don't have a question, keep going, or it's just I don't understand, but I'm too embarrassed to raise my hand because I think everyone else does. Or the third one, this is usually the case, is I'm so damn confused I can't even ask a question. And so you don't get any of that sort of feedback. So you're just running open loop giving these lectures. And I think that's more of a challenge in engineering than the history of rock. We're trying to, we're bludgeoning them with some mathematics and whether or not we have to see how they recoil. I said the assessment is difficult. Having all those students, boy, you can't make a mistake. The minute you mess up a minus sign, you get email from Bulgaria, to straighten it out. And so some of the surprises in all of this, and these are pleasant surprises, is the students were much more committed than I would have thought they would be to a free thing. They're just. Some of them were the ones who completed were very worried about their grades on the exam. In fact, we even got an email from one student who asked if she could use a crib sheet in taking the exam. And how the hell do we know what's going on out there? We don't care. And so we said, sure, it's whatever, crib sheets are okay. And the other thing is that they were the ones who registered for it really wanted that certificate of completion. So having some kind of credential in their hand when they were done was very important. The other thing that was really a pleasant surprise was to see how these forums took off and how how active those became immediately. And so that's really, that happens spontaneously, and it's a very gratifying thing to see that happen. And it's the same thing John said, that students really kind of take ownership of what's going on in the course. Now the other thing I noticed, and maybe this is a little more true in an engineering or a technical course, but there was a lot of interest in some of the students of having some kind of a credential. And we received correspondence from people who wanted to put it on their they were working as an engineer and they wanted to count it as continuing education and things like that. And so I think this is a really interesting question to be considered about how this is going to evolve. You know, whether or not universities are going to somehow take ownership of the credentialing part that goes along with this, or probably, my guess is there's going to be some other sort of evolutionary thing that's going to happen that we're not going to, probably not going to control that process, but you know, people are just going to, they're already doing this. They're starting to list their completed Coursera courses on their resume and things like that. And so, so the credential part of this is an interesting discussion. So a few of the conclusions that I made, and this was already mentioned, is that how the majority of students had not heard of the U of R before, so what a great marketing tool this is. Now, it's still, I think, an open question whether we're reaching the students that are going to actually come here for college eventually. You know, some kid in Bulgaria just may not have the opportunity to come here.
It's okay if you get a friend too.
Yeah. So, but that's an interesting question. But I think more importantly, at least in my own personal experience, is that running a MOOC is kind of, you're doing things in a different way, and it makes you kind of stop and reflect on what you're doing here in our regular, in our day job. And and what I really mean by that is it sort of makes you go back and appreciate being able to give a live lecture and take advantage of the feedback that you have and the you know, the end of the one-on-one interactions with the students, which is you know, our unique, you know, the residential unique capability. And so the question is, are MOOCs a threat to residential universities? And I think I certainly agree with John. No, they're not. But I think that they are an occasion to sort of reflect on what it is we can do best here in the residential setting, and then rededicate ourselves to doing that. Now, just a little bit more on the learning by doing theme. And this isn't just for engineers. You know, everyone. I was having a committee meeting with some people talking about portfolios, and one of my friends in humanities was not getting it, and I said, "Well, surely you must do something." And so everyone does something, especially after they graduate, and. So I think that we all need to look at ways to engage our students as much as we can in sort of the learning by doing paradigm, and this is not just in engineering. And perhaps some of these materials that we're creating in MOOCs can be used, as John was discussing, to free up other lecture time so we can do other things, you know, more personal interaction with the students. And the other thing that I think that would be easy for us to do that we just don't seem to do consciously is to sort of encourage the formation of the small learning groups among the students. It happens spontaneously here, study groups and that sort of thing, but I don't think it would take much to optimize in that dimension. And this is just my own personal axe to grind here, is talking about having evidence of the accomplishments of the students. And so, like in this new audio and music engineering major we started here, the whole thing is built around this portfolio idea, which is just a record of everything they've accomplished. So the last slide here is, I guess I'm trying to answer the question posed by the title, is should we be engaged in MOOCs? Well, definitely. I think we'd be silly if we weren't. And this is repetitive now, but it's really a great way to communicate the strengths of the university out there. Now, we didn't even compare notes before we got here, and so we're all saying the same thing. And now the current format for MOOCs is still far from ideal, and I think that I've never taught the same course twice ever in 28 years, and I'm never happy with it, and the same thing goes for MOOCs. And so I think that we have to keep experimenting and probably find better ways to do assessment and feedback and to take a more active role in the forums. That was probably the biggest criticism we got. We were just overwhelmed with the amount of stuff coming at us in the forums, and I could have spent 8 hours a day just reading those things and answering email, but you run out of time. And so I think the bottom line here is that this experience and doing things in this very different way is a really good occasion to kind of reflect on what we do here already and hopefully make us better educators at what we do here now. So that's it for me. So we're done.